Hey there, have you ever played an automation game before, such as Factorio or Satisfactory? Well, I'm trying to teach myself game dev, and I thought that I'd try and recreate the basic building blocks of those games. And this involves having a modular set of buildings that are able to connect to each other. So, for example, in Factorio, the miners produce iron ore, which are then transported by the belt and inserted into furnaces. Broadly speaking, buildings in Factorio either produce items, consume, or do both at the same time. When applied at scale, this concept can lead to surprisingly complicated builds and large factories. Since I'm new to game dev, I thought I'd just try to make the basic setup of having some miners feeding ore into furnaces via some belts. I already have some programming experience with C++, so I decided to use Unreal Engine 5 to make it all. So when I first created the project, I was launched into a third-person starter environment. Since I wanted the focus to be on the buildings and not the character, I needed to change this. I quickly started working on setting up a top-down camera. I was able to remove the existing player model and set up a first-person player character with the camera orientation facing downwards. I wanted the camera to move up, down, left, and right, and for it to speed up when I press shift, similar to a sprint. Implementing this movement is where I encountered my first hurdle though. Grabbing inputs from the computer can be cumbersome, especially if you want the game to support multiple platforms and multiple different types of inputs, such as keyboards and controllers. The framework that Unreal Engine uses to manage this is called input mappings. This lets you link a specific input, such as a mouse click, and assign that to a certain action. So, for example, you could use the spacebar or the A button on an Xbox controller to perform a jump. This works great for what I want to do, except I didn't end up using it. What I did instead was use the Enhance Input plugin. So if you got the same single brain cell as me, you probably thought of Enhanced in the Enhance Input plugin part and thought, ooh, shiny, right? And let me use that. Well, turns out that it's pretty over-engineered for what I want to do. And basically the aim of the Enhance Input plugin is to provide a framework for managing multi-layered input scenarios. So let me explain here. There are three main components to the Enhance Input plugin: input mapping contexts, input modifiers, and then the input triggers. Input triggers let you customize the way an input should be registered. For example, you can choose whether an event happens when a button is pressed, held, or released. This is great for stuff like action games, where the attack can be different based on whether you press or hold a button. Next, input modifiers can change the signals that are sent to the input triggers. For example, if you want to implement a controller dead zone, where the center of the joystick doesn't trigger actions, even if it's slightly moved, you can do it with an input modifier. The modifier will intercept the input signal from the controller and cut off any values that are below a threshold. Lastly, input mapping contexts then control what set of input modifiers and input triggers are used in different situations. For example, the controls for walking and driving a car are different. When a player is in the car, the input mapping context for driving a car will be used, and that will load the input modifiers and triggers for driving. When the player exits the car, then the input mapping context for walking is loaded, which then uses the walking modifiers and triggers. Essentially, input mapping contexts offer a way to switch between different input systems dynamically when the game is running. So coming back to what I want to do, I need to be able to move the character forwards, backwards, left, and right, as well as speed it up. But this means I won't end up using most of the functionality that the Enhance Input plugin provides. It was only after implementing everything that I realized I over-engineered things. Well, at least it works. Now that the player can move around, I need a way for them to be able to place buildings. My idea is to have a few buttons to show up on the screen, and then the player can select which building to place with. Now, Unreal Engine has two ways for implementing user interfaces. One is the Unreal Motion Graphics, or UMG editor, and the other is the Common UI framework. Common UI builds out additional functionality on top of Unreal Motion Graphics, but that also means it's a bit more complicated to set up. Being the smart man that I am, of course, I decided to go and learn the Common UI approach because I couldn't help myself when there's something fancy like that. Now, I'm going to be honest here. Common UI was a pain to work with. So let me show you what I had to go through. I started off with the input action data table. Here I created an abstract representation of an action, which can be called something like select. I then linked the keyboard and the controller buttons that would activate that action, so when I press these buttons, the select would be triggered. Next, I needed an input data blueprint. A blueprint in Unreal Engine can be thought of as a type of container that holds data. In the input action data blueprint, I entered the input action data table that I created earlier, as well as some default actions for navigating the UI. Afterwards, I had to create one controller data blueprint for every input device I wanted to support. I created one for a keyboard and another for an Xbox controller, since those are the only two I have. In these blueprints, I also entered the icon images for each key or button. After I created the input data blueprints and controller data blueprints, I needed to select them in the project settings, otherwise it won't be picked up by Unreal Engine. Now that I have set up the different inputs, I needed to create the actual buttons. In Unreal Motion Graphics, the building blocks of user interfaces are called widgets. With these widgets, I can create buttons and add text to them. Common UI has their own special widgets, such as the Common Activatable widget. This lets me enable the back handler, auto activate, and auto restore focus functionality, which are unique to Common UI. The benefit of this functionality is that if I have multiple menus, which would overlay on top of each other, the order which they appear and disappear are automatically handled by Common UI. To edit the colors of the button, I had to create a style blueprint as well. This contains information such as the colors. The idea of this is to make it easier to replicate styles across multiple different types of buttons and user interface elements. But it does add the overhead of managing these style blueprints. So after following a tutorial and spending a few hours of pain to get all this working, I created a main menu. But it was at this point that I realized the Common UI framework is far too cumbersome for what I wanted to do. I'm nowhere close to utilizing the functionality that it provides. Instead, it was slowing me down with the complexity. All I needed were a few simple buttons, so I pivoted to using the simpler Unreal Motion Graphics editor. Since Common UI is built on top of Unreal Motion Graphics, many concepts transferred over. All I needed to do was to create one widget blueprint for the button and another for the heads-up display. In the heads-up display, I then placed 3 instances of the button. When one of these buttons are clicked, I then would route the buttons on click event to spawn a building or to print a message. I also set the style components of these buttons as a variable so they can be adjusted to have different colors. And that is the UI done and dusted. Now that I had a way for the player to tell the game to spawn a building, I had to figure out where the buildings could be placed. What I want is for the player to be able to select the building from the UI and then place it at the location where the cursor is. To do this, first off, I needed to create the building that is going to be spawned. I made a simple actor that has a cube and some text as a mesh. In Unreal Engine, an actor is just anything that can be placed in the world. Next, I needed to spawn in the building at the cursor location and get the mesh to follow the cursor. I hooked up the first button on my HUD so that when it's pressed, it would call the start placing building code in my player controller. In the start placing building code, I spawned a temporary building at the location of the cursor with collision disabled. Disabling the collision is important because every frame I use Unreal Engine's collision system to get the coordinates where the mouse cursor is. The temporary building's position is then updated to be at the same coordinates. Since this is run every frame, this gives us responsive controls over the building location, and the building will follow the cursor around. With this, I can spawn a building at the mouse cursor's location. There's a good reason why I have to disable collision. If I enable it, stuff breaks very quickly. That's because after the temporary building's position is set at the mouse cursor, in the next frame, the collision result will be on top of the same building. This repeats, and then I get a runaway effect where the buildings spawn higher and higher, and you get a giant tower very quickly. To make the building snap to a grid, a small bit of math is needed to round the cursor coordinates to the nearest grid size. Now that I can spawn the building, I needed a way to save its location. I set up an input action so that when I click, it'll trigger some code to confirm the placement. This destroys a temporary building that's following our cursor and places a copy at the same location. Now, everything is working. I also hooked up some code so I can cancel the building placement by right-clicking. Afterwards, I went ahead and made 2 more buildings, a belt and a furnace, both of which are cubes for now because I'm lazy to model it. I also hooked up the 2 remaining buttons in the UI to spawn them. Now that the buildings can be placed, I needed a way for them to be able to connect and pass items to each other. To get a basic case working, if 2 buildings are directly adjacent to each other, and if building B is directly in front of building A, then building A can send items to building B. I thought of 2 ways to implement a system that can tell when buildings are next to each other. The first is to have a centralized system that tracks the locations of the buildings on the map. The system will be able to tell if buildings are adjacent to each other. The good part about this is that all the logic is managed in one place. Well, the bad is that I will have to implement a custom tracking system. This tracking system will need to maintain the locations of all of the buildings, as well as the order in which they pass items to each other. The second approach was for each individual building to track which other buildings are directly adjacent to itself. The good part is that each building has relatively few things to keep track of. It only needs to know what is directly next to them, as well as the building it's going to feed items to. The bad part is that the logic is now split up between every individual building, so debugging the system could be difficult. In the end, I ended up using the method where the buildings keep track of other buildings. This seemed easier to implement than the centralized system, which seemed a bit too cumbersome to do. Next, I needed a way to tell what direction a building is facing. Luckily, actors in Unreal Engine have a built-in forward vector. A vector is a maths tool that represents a direction, and the forward vector points in the direction of the front of the building. With that, I know which direction the camera will send items to, and I've added an arrow to show that as well. In order for items to flow between buildings, each building needs to know who it should be producing items to. I decided to calculate this during the building placement code. When a building is placed, I use the forward vector to perform a collision check in front of the building to see if there is anything there. If there are, the current building saves the building in front as a production target. There is an issue with this implementation though. If I place the buildings in a different order, nothing gets registered. To solve this, I needed to check for adjacent buildings in the other 3 directions as well. If those neighboring buildings exist, the newly placed building would tell those neighbors, hey, I exist. And then those neighbors can register the current one as a production target. With that, I can place the buildings in any order and they will be connected. Next, I needed a way to track when items are passed between buildings. This has a few steps, and first I need to figure out what an item looks like in the code. At this stage, I chose to represent each item as an enumeration, which is essentially just a piece of text that's easy to pass around in the code. This is used in each building to track what item it's currently holding. For now, I have limited it so that each building can only hold one item. Next, I needed a way to tell the buildings to periodically make new items. For this, I created a timer that runs every second. When the timer activates, it will loop through all the buildings and then tell each of them to produce an item. I then attached some logs to tell when a building is producing or receiving items. and now I can see it working. There is one big caveat to this though. The logs create an illusion that the items are smoothly traveling from one building to another. But in reality, this is far from the case. All this will become a lot more obvious when I start implementing the animations. Before I can begin animating the item movement, I first need a visual representation of the item. I'm lazy, so I use a simple code for now. To link this mesh to a particular type of item, I went ahead and made a class for the item. A class is a programming concept that lets me store any information I want about a particular thing. For this case, the item class will store the type of item as well as its mesh. This is more powerful than the enumeration I had earlier, as that can only represent the item type. I then modified the building code to use these item classes. To spawn the mesh, I've hooked it up to the same code in the buildings that would create a new item. Next, I needed a path for the items to travel along. This can be done with a spline component, where the item will travel from one end of the spline to the other. To keep things simple, I am using a straight line, but the spline can be adjusted to fit any type of shapes. Like other factory games, I plan on supporting many items on the belts at the same time, without abysmal frame rates. Unreal Engine provides a way of rendering many items efficiently, and that is through instanced static meshes. I am specifically using a hierarchical instant static mesh because it works well with simple meshes like the ones I have. The instant static mesh reduces the performance and memory cost of rendering many items because it combines the lookup costs for each instance. Implementing this meant that I had to write some code to manage the mesh instances. I put this in the same class that has the item production timer. When a building produces a brand new item, I created a new mesh instance at the same time. This mesh is spawned at the start of the current building spline, and I set up some tracking data to store how far it has moved along the spline, as well as which building owns that item. To make the items move smoothly, I need to update their location every frame. This involves 3 core problems that I need to solve. The first was how to move an item at the same speed, regardless of the frame rate. I can't move the items the same distance every frame because then the movement speed will change depending on the frame rate. I need to calculate the distance based on the time elapsed since the last frame.
So if we take a look at the physics equation here, where distance equals time multiplied by velocity, we can use this to calculate how far our item should be moving. So the distance moved per frame is the time elapsed since the last frame, and multiply that by the length of the spline and the rate of production to give us the velocity, because the rate of production is how many items will travel through the building at any one point. And multiplying that by the length is the velocity.
The second problem to solve was how to transfer an item from one building spline to another. When an item has reached the end of the current spline, I need to check if there is another building to hand over the item to. If the next building exists, I swap out the current spline for the next one and switch over the ownership of the item. If the next building doesn't exist, I keep the item at the end of the current spline. The third problem to solve is how to delete an item from the world. Well, before that, I need a way to know if an item needs to be deleted at all. I set up a method in all the buildings to return whether it is a sync node or not. Being a sync node means that the building consumes items permanently. When an item is held by a sync node building, it needs to be deleted safely. I wrote some code to destruct the item class and remove the instant static mesh from the world when it has reached the end of a sync node spline. Now, when we run the system, we can see the items spawning at the miner. Some move forwards, and others are stuck, and some even teleport for some reason. Well, something isn't working correctly, and it turns out that it's an issue with the logic system and the animation system not being in sync. Every time the timer in the logic system runs, the code would loop through the buildings in the order that they were placed, and tell each building to process an item. This sounds fine at first, but this is actually what's causing the teleporting bug. If the buildings are placed in the same order as the direction that the items travel in, then it's possible for one item to travel through all of these buildings in a single run of the timer. This is because one building would pass the item to the next, and then to the next, and so on and so forth, until the last building is reached, all within the same loop. The solution I settled on was to process the buildings in 2 batches every time the timer runs. The first batch are the producers, which are buildings that can output an item. Currently, that's the miner and the belt. When the producers are called to make an item, they first check if they are able to send the item to the next building. If they can, the item is registered as ready to send, and the receiving building is notified that it has an item incoming. Importantly, the item transfer has not occurred yet, and this is just updating the internal states of the buildings. After the producers have finished processing, the consumers are processed next. Now, the consumers are buildings that take in items, which are the belts and furnaces right now. They check if there's an incoming item and whether they are able to accept it. If both are true, the item is transferred from the producer to the consumer. Afterwards, the internal states of both buildings are updated so that it is able to process another cycle. This way of splitting up the producers and consumers means that I no longer run into the teleporting issue. Finally, everything is working the way I intended. When I was testing the system, I also added 2 buttons to start and stop the production and consumption logic. Additionally, the number above the buildings shows how many items have been processed by each building. Oh, how beautiful it is to see cubes feeding cones to other cubes. Like and subscribe. Bye bye.